Okay. Connor.
N and P and Q.
You got it. So I'm going to highlight and outline these. So triangle M and P, which I'm outlining in green. That's going to overlap with triangle MOQ. So I highlighted them. Now I'm going to redraw them. So we have triangle M and P and MOQ. Now go back to the overlapping triangles, the original diagram. Do we agree both these triangles have an angle M in it? Both triangles have an angle M. But go back to the original diagram. Is it the same exact angle M in both triangles? No, they're different angle M's, right? One is angle NMP and the other is angle QMO. They're different angle M's. So this does not count as a reflexive angle because they're different angle M's. The only time it counts as a reflexive angle is if it's the same exact angle M. So that brings us to number 2. So I asked for 2 pairs of overlapping triangles. The first one that has a reflexive angle, the second one has a reflexive side. Did anybody find either one of those pairs of overlapping triangles? James. Excellent. Now, do they have a reflexive side or a reflexive angle, those two? Those two have a reflexive side. I'm going to highlight. So FEI, that's one. And the other one is HEI, which I'm highlighting in yellow. If we look at the bottom, isn't EI the same in both triangles? Yeah, EI is the same in both triangles. All right, so that was the overlapping triangles that had a reflexive side. Now I asked you to find 2 overlapping triangles that had a reflexive angle. Only 2 people? 3? Charlie? EHG and IFG. Perfect. So I'm going to outline it. So here's IFG. I'm highlighting it or outlining it in blue. And the other one was triangle GHE, which I'm highlighting in yellow. Okay, so go back to your original diagram. That angle G on top, is it the same exact angle G in both triangles? Yeah, it's the same exact angle G. That's why it's considered a reflexive angle. We've never seen a reflexive angle before. This is the first time, but now it's going to come into the rotation of things we look for. All right, so today we are not learning any new theorems or postulates or definitions. There is nothing new for you to memorize. So today we're going to do along the same lines of what we've been doing, proving triangles congruent, CPCTC, maybe beyond CPCTC. But now it's just going to be in a different format. We're going to have diagrams or triangles that are overlapping, diagrams that are visually maybe a tad bit more difficult than what we've seen before, but nothing you can't handle. So let's go into our first problem. This problem's really nice because I'm telling you which triangles to prove. I'm telling you which triangles to prove, therefore there's no confusion on your end. There's no guessing, am I choosing the right triangles, am I not? That is the best scenario here. Go through, let's mark up our given. Hi, you're hanging out with me?
Just study really quick because I'm about to take a test.
Okay, so here we have segment PT is congruent to segment RS. Then we have segment PQ is congruent to segment RQ. That's all of our given, and now I'm going to highlight what we want to prove. We want to prove triangle PQS. I'm outlining this in blue. Congruent to triangle RQT. So now that I know which triangles I'm going to prove, I've highlighted them. Now I'm going to redraw them so they're not overlapping. You do not have to do this next step. You do not have to redraw them if you don't want to. Sometimes it's visually just easier to see what you have if you redraw them, but it's not a must. Now I'm going to re-go through my given information again and ask myself, is it enough? So segment PT and segment SR, do they count as full sides of the triangles we're proving? PT and SR? I see some people nodding. I see some people shaking. No, PT is not a full side. SR is not a full side. So does that count as an S for us? No. Let's keep going. QP and QR, do those count as full sides? Absolutely. So I'm going to mark that on my pulled apart triangles. QP and QR counts as a side. So at this point, after going through my given information, I only have a side. After going through the given information, I only have a side. Go back to our overlapping triangles. Is QT a full side of the yellow triangle? Is QT a full side of the yellow triangle? QT? Q to T, right? Trace it. Q to T, that's a full side. Is QS a full side of the blue triangle? QS? Yeah, QS is a full side. Trace it. Is there a way to get QT congruent to QS based on how we've labeled things right now? Absolutely. How? How can I get QT and QS congruent? Bridget? Subtraction, you got it. I'm going to say that QT is congruent to QS subtraction. That really helps us. So I'm going to mark it on both triangles. So now we have two sides, an S and an S. SS, is that enough? No. Go back to the original. Remember what I said. Once you've gone through all of your given information and you've made conclusions, you either look for vertical angles or you look for something reflexive. I do see vertical angles here. There's actually two pairs of vertical angles, but there's floating around the middle. Do you agree? Those don't count. The angles have to be actual corners of the triangles to count. It can't be swimming in the middle. That doesn't help us. So vertical angles not helpful here because they're not corners of the triangles. Does anybody see something reflexive? Emily? Angle Q. Isn't that the same exact angle Q in both triangles? Yeah. So we're going to say angle Q is congruent to angle Q reflexive. Alex, where are you supposed to be?
I gotta go to math lab.
You gotta go to math lab.
Yeah. Alright, I'm gonna go ace this test. I'll come talk to you later.
You got this.
Alright, see ya.
Bye. Good luck.
Thanks.
All right, so now can I say the triangles are congruent? Sure. Triangle PQS is congruent to triangle RQT, and that is SAS, side angle side. And we're done. So when I actually tell you which triangles to prove, it takes the guessing game out of the problem. Let's go on to where I don't tell you which triangles to use and see what happens. Anybody still copying number 1? Okay, number 2. Okay, again, let's go through our given, mark up what we have. So we have DB congruent to AC. So this whole segment congruent to this whole segment. Then we have that AD is congruent to BC. And we want to prove that angle D congruent to angle C. We need to prove those two angles up top. So your plan should be to find triangles that have those two angles in them. Do you all agree that triangle DEA and triangle CEB I'm choking, give me 1 second. All right, do we agree that triangle DEA and DEB have those angles in them? Yeah, but don't force it. Try it, but don't force it. So DA and CB, those count as sides, right? But does DB and CA, do they count as sides? No. At this point, I've seen people say bisector, that AE and EB are congruent and DE and CE are congruent for whatever crazy reason they've come up with. Is there any reason right now we can conclude that DE and CE or AE and BE are congruent? There's no reason we can conclude that. Do not force it. If it doesn't work, do not force it. Can you say vertical angles for these two? Yeah, but then ultimately it's just a side and an angle. A side and an angle is not enough, and there's nowhere else to get another side or another angle. This is what I mean. You can look, but you cannot force it. These two triangles will not work. So now you need to choose a different pair of triangles that we can get congruent. Does anybody see a different pair of triangles that may be overlapping that we can get congruent? Adam.
Triangle ADB and triangle BCA.
You got it. So we are triangle ADB right here that I'm highlighting in yellow, and triangle CAB, which I'm outlining in blue. So now I'm going to redraw these triangles. Okay, so here are the two triangles. Now let's go through the given again, see what counts for us. All right, so we had DB congruent to CA. That counts as sides. Full DB, full CA, we're good to go. Then we had AD and CB. That also counts as a side. So now we have two sides, an S and an S. We need one more piece. Olivia.
If
AB is reflexive. You got it. So we're going to say AB congruent to AB reflexive. So now I can go on and I can say triangle DAB. Now I said triangle DAB. Who's going to match it up for me? Adam.
CAB?
CBA, good. Then that's going to match with triangle CBA. And what is that reason going to be? SSS. Now that the triangles are congruent, I'm going to look. We need to prove D and C congruent. Are angles D and C part of those triangles? Yeah. So then I can say that angle D is congruent to angle C. Who knows the reason? Jocelyn? You got it, CPCTC. Not congruent parts, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. All right, can we move to the next one? Anybody still copying? All right, the next one. All right, so here we have the full segment FH is congruent to the full segment MJ. Then I see double midpoint. What should I be thinking if I see double midpoint? Charlie. You got it. We're going to use multiplication or division. Because I'm going to use multiplication or division, do we need to go through the function of a midpoint? No. Because we're going to use multiplication or division, we do not need to go through the function of the midpoint. So let's keep going. Now we want to show, now we're being told that angle GHJ, not triangle, angle GHJ, this angle, is congruent to angle KJH, which is this angle right in there. What is it that we want to prove? I will highlight what we want to prove. We want to prove that GJ is congruent to HK. We need triangles. When we can't prove what we want from the given information, we prove triangles congruent. Which triangles do you think we're going to focus in on? Which triangles do you think we're going to focus in on? Only Adam knows, and Bridget and Charlie. Connor, which triangles?
GHK and KJG.
GH, say it one more time, GH.
Okay. And
GHK is not a triangle. GHK, that's not a triangle. Say it one more time, GH.
the other one's kind of the same thing, so they're both not triangles.
Okay. Adam?
GHJ and KJH.
You got it. GHJ. Connor, we see?
Yep.
And KJH. These two triangles. So I'm going to redraw them. All right, now let's go through my given information again. FH and MJ, do those count as sides for our triangles? No, but keep in mind, we were told that G is a midpoint and K is a midpoint. Wouldn't it be nice to get GH and KJ congruent? Well, if the full segments are congruent and G cuts in half and K cuts in half, are our half segments also congruent? Yeah, what is that? Chase? Definition of midpoint would get FG and GH congruent on the same side. That's the definition of midpoint. I need left and right congruent. I need GH and KJ congruent. You want to try again? The full segments are congruent, right? And G cuts in half and K cuts in half. So if the full segments are congruent, are their half segments also congruent? Division, you got it. So we're going to say that GH is congruent to KJ division. So I'm going to mark that. Right. Then we had the angle GHJ, which counts for us, and KJH, which counts for us. So we have a side and an angle, not enough. What else can we say? One side, one angle, not enough. What else can we say? Maya, what else can we say? You got it. HJ is congruent to itself. So now I can go on and say triangle GHJ is congruent to triangle KJH. And the reason is SAS, side angle side. Can I now get GJ congruent to HK? Yes, GJ congruent to HK. What's the reason?
CPCTC.
CPCTC, you got it. I'm going to skip number 4 right now. We'll come back to it. I'm going to actually have you do number 4 on your own. And then the 2 that say independent, I'm actually going to do them with you. Charlie?
For the previous problem, angle GHJ, that's part of 2 triangles, so wouldn't you have to mark them maybe like angle 1 and 2 and then prove that 2 is congruent, like the smaller angle is congruent to the other smaller angle?
I see what you're saying. So for this one, we're going to do something similar to that coming up, but I think you're confusing it a bit. So for this one, angle GHJ, isn't that the full angle H in the yellow triangle? So numbering those inside angles aren't going to help us here. And look on the other one, KJH. Look at the blue triangle. Isn't angle KJH a full angle, that full angle J in the blue one? So they count as full angles as they are. We don't need to do anything else there. You're going to see in the next problem, I'm going to do something similar to what you're talking about. But do you see why we didn't have to do that here? Okay. So we're going to skip number 4. Let's go to independent number 1. We're going to go through this together. All right, so here we have angle 1 is congruent to angle 3. And we have angle 2 is congruent to angle 4. We want to prove, I'm going to highlight it, we want to prove that BC is congruent to ED. So for me personally, my first instinct for triangles to prove congruent is our triangles BCF and EDF. Do you all agree with, do you all see those triangles? You don't have to agree. Do you all see those 2 triangles, BCF and EDF? Don't highlight it because these are wrong, but I'll highlight them for you. So I'm talking about this one and this one. Well, we do have angle 1 and angle 3. That counts as an angle. Can we also get vertical angles? That counts as another angle. Does anything else count? No. Do we force it if it doesn't work? No, we don't make stuff up. Because the minute you start making stuff up, this is when we get into like negative territory. This is when I can start taking extra points away from you by stating things that aren't true. You're better off not stating anything versus stating something that's not true. These do not work, right? So we can't use these triangles. So now I need different triangles. Does anybody see a different pair of triangles that we could potentially use? Adam.
CBD and DEC.
You got it. CBD, this bottom one, and ECD, this blue one. I'm going to redraw these triangles. Okay, now let's go through the given information again. It told us angle 1's congruent to angle 3. Look at the triangles. Angle 1 and angle 3. Do they count as full angles in either triangle? No. So does that count as an angle for us? No. Stay with me. Then it says angle 2 is congruent to angle 4. Follow the triangle ECD. Is angle 2 count as an angle? Yeah, that is a full angle in the blue triangle. The different colors really help. Is angle 4 a full angle in the yellow triangle? Yeah. So I'm going to label those in my separated triangles. Angle 4 is angle BDC. That's right here. And that's congruent to angle 2, which is angle CECD, which is right here by angle C. That counts. Does anybody see how, going back to the overlapping, yes? It is labeled incorrectly. That's a D on the bottom. Sorry. Better? Thanks. All right, go back to our overlapping triangles. Does anybody see how I can get this angle, big angle by C, so angle BCD, this big one, congruent to this big angle by D, EDC, this big one? Yeah? How? Chase? Addition, you got it. So we're going to go through, and I'm going to now, I have to label this with 3 letters. I can't put a number there because the numbers are all taken on the inside. So we need to name it with 3 letters. These are not triangles. These are angles. Angle BCD is congruent to angle EDC. Addition. Yes, Adam. Oh, okay. So that gives us the big angle by C and the big angle by D. So I mark that. So now we have 2 angles. What else can we say? What else can we say? Soph, what else can we say? You got it. CD congruent to CD reflexive. So now, can I say the triangles are congruent? Yes, triangle BCD. Now, I said triangle BCD. Who's going to match it up for me? I said BCD. Charlie? EDC, you got it. And that is ASA. Now that the triangles are congruent, can we now use CPCTC? Yes, just to make sure. Are BC and ED full sides? They are full sides, so I can say BC congruent to ED CPCTC. All right, last one together. Give me a second to catch up. Anybody still copying? Okay, next one. So this one is going to go beyond CPCTC. We're going beyond CPCTC for this one. So here we have segment OP is congruent to SR. We marked it. Then we have angle OPR. So that's this big angle is congruent to angle PRS. This big angle. And last but not least, we have segment PT is congruent to segment TR. I'll highlight what we want to prove. We want to prove that OT congruent to ST. All right, do not write this. Do not write this. I'm going in on these 2 triangles. All right, in those two triangles, OP and SR, they count, right? PT and RT, they count, right? Does the big angle P and the big angle R, they count? No, they're too big, right? But could I do vertical angles? I can do vertical angles here. But when I do the vertical angles, isn't that ASS? Are we allowed to use ASS or SSA? We're not allowed to do it. Do I just force it and say, oh, that's just SAS? It's not SAS. We can't call it SAS if it's not SAS. So do these triangles work? These triangles do not work. So they do not work, so we do not force them. All right, so now let's prove a different pair of triangles. Even if it's not ideal, any triangles that we can get congruent. Does anybody see a pair of triangles that we can potentially get congruent? Aaron.
Triangle OPR and triangle SRP.
You got it. Triangle OPR, which I'm highlighting in blue, and triangle SRP, which I'm getting off in yellow. I'm going to redraw them. So we are at OPR and SRP. All right, OP and SR, they count. Angle OPR and angle SRP, those two angles count. Does segment PT and segment RT, do they count as full sides? No. So I need something else. I have a side and an angle. I have a side and an angle. I need something else. Caleb, what do you see?
PR is reflexive.
You got it. PR reflexive. So my step number 2, I'm going to go ahead and I'm going to say PR congruent to PR reflexive. And now I can say triangle OPR. Adam, I said triangle OPR. Can you match it up for me?
OPR, then it's SRP.
SRP, perfect. And that is SAS, side angle side. Can I CP, CTC, OT, and ST? I see everyone shaking their heads no. Why not? Why am I not allowed to say OT is congruent to ST and the reason CP, CTC? Why no? I know. Connor, why no? Why am I not allowed to say OT and ST are congruent by CP, CTC?
Because they're just meeting in the middle of the arc.
Yeah, they're not full sides, exactly. They're not full sides. If they're not full sides, we can't CP-CTC them. But is there a side that contains OT and a side that contains SR, ST that we could potentially CP-CTC? Yeah, Charlie, which ones? You got it. I'm going to say that OR is congruent to SP, CP-CTC. Well, now that I got this full side congruent to this full side, and didn't they tell us the bottom parts are congruent? So how can I get OT and ST congruent? For what reason? Emily, you got it. All right, so that is the end of the problems we're doing together. You do have homework tonight. Charlie, you're going to need to grab a textbook from the back and give your old textbook back to Mrs. Sultan.